Hi everyone, welcome to this Hong Kong Interior Design Construction Society Management Study course. Today we talk about construction of building, the structure of building. Okay, let's get started.
Once two strangers climbed old Rocky Top looking for a moonshine still. Strangers ain't come down from Rocky Top, reckon they never will. Corn won't grow at all on Rocky Top, dirt's too rocky by far. That's why all the folks on Rocky Top get their corn from a jar. Rocky Top, you'll always be home sweet home.
These are the contents of this edition. And mainly we talk about the types of structure of building. Of course, we won't talk in very detail. We just talk about briefly talk about the structure types of the common buildings. We also talk about some building components like foundation, floor, wall, and roof. Just general knowledge about it. Let's see. These are timber structure. Of course, timber structure now is not common, especially in Hong Kong. It's still very common in maybe in the United States or areas where timber are abundant. Or in the ancient times, you see this Chinese structure mainly made of timber. Now it's not common in Hong Kong, so even in China it's not common. So let's skip this section. Now, brick and timber structure. Maybe it's not common now. It's an old building, 100 or 200 years ago in Hong Kong. It's become antique building. But in Europe or America, it's still very common. You can see the whole street of this kind of building. It's brick and timber structure. It's mainly made of brick. You see, timber for the floor, timber for the floor joists, timber for the ceiling, and timber for the partition and stair. The flooring just rests on the brick wall. You see, here, you can see now the section here is the brick wall. And this is the timber joists, the floor joists, and the timber stair. Now for brick wall building. This is the tallest brick wall building in the world. It's built 1893 in the United States, Chicago. The main structure is built of brick. It's a 12 floor. This foundation, the brick wall on the foundation, around 6 feet wide, so very wide. And iron frame floor. This floor joists are made of iron or steel. You see, in 1893, maybe the lift and the lighting is still just invented at this time. So this is the tallest in the world. It's still there in Chicago. This building is still find it in Chicago. Now, whenever we talk about structure, we mean the load bearing structure. The structure is not the component or the construction. It's the structure means load bearing. See this brick and concrete structure. You see, in brick and concrete, both brick and concrete are structural component. You see, it is this brick wall. It support the floor, the concrete floor. So it's concrete and brick wall structure. Just see here. If we move this brick wall away, it will collapse the slab, the concrete slab. This is a very economical building in rural area. You see this concrete slab, reinforced concrete slab. Now it's still you see in some suburban area in China. Comes to big and tall building. Big and tall building it happened more than 100 years ago. It built of steel frame. You see the steel frame, like frame, column, steel column, and steel beam, joined together with bow and nut. You see here, it's pre-made in the factory and assembly on site like that. You see the column is covered with masonry, with brick for fireproofing. You see this is an old building in Hong Kong. It's a bank building. It's demolished already. Follow the steel frame building, then we have the concrete reinforced concrete building. It's invented in France, 1819, or more than 100 years. You see the buildings are made of in-situ concrete, monolithic. There's the wholly in-situ, wholly concrete column, concrete beam, concrete floor, poured on site. You see. It's the concrete frame, the framing, and that is called a shear wall. The shear to resist the window, the literal force. The window from the side is the literal force. This is a brick for weather protection only. They are not load bearing, so they are not structure. You see this wholly concrete underneath it with a recessed column, because the outside are curtain wall. You see this building mainly in shear wall construction, concrete wall. The toilet and the kitchen wall are in block, light concrete block. Okay, after the concrete construction, the monolithic concrete construction, we have the steel concrete composite structure. That is made of concrete and steel frame, like this one. Then with the concrete core. Here the concrete core, surface core, encloses the lift shaft, the lavatory, the air conditioning room, and pipe duct, etc. Mainly for the surface. The floors and steel decking. You see curtain wall outside. But this structure is also a steel concrete composite structure. You see this is the concrete here. In situ concrete, you see, and the upper structure is in steel frame. Come to the foundation of the building. You see, this is the peg footing, we call it. Under column, independent peg footing. Footing is independent of each other. If it is a tall building, then we use a pie cap, and then use the precast piles, concrete precast piles, down to the structure. That's the stone layer of the ground. If it's a lot touching the stone layer, then we call it the friction pile. You see, we use the friction to bear the load. Now this beam is called the ground beam, like this. It's touching the ground, so we call it the ground beam here. Now this is called a cellular wall foundation or box foundation. It's a big slab of foundation or box foundation for the basement, for the car park mostly. Also we have the in-situ pile. You see this in-situ pile. We bore a hole, make the steel reinforcement, and pour the concrete. This is called in-situ pile or caisson pile. Caisson means the box, the steel box, mostly used in foundation with underground water or marine construction. The caisson means a steel box. So we talk about the flooring. For steel framing structure, the steel deck, this steel decking. We rest the steel deck on the girder or the beam, the framing beam, and pour the concrete on top of the metal decking like this. This is the main column, this girder. Now we can still see this kind of falling structure. For low-rise house, the ground floor is constructed like this. This is the hard core. The dam-proof membrane. This is the dam-proof membrane. And we pour the concrete on top of it, mostly with foul reinforcement, with the screening, you see. This is the outside wall, two-layer, we call it KVT wall. This is the dam-proof course, for the dam-proof of the wall. This is the in-situ concrete of the floor. You see, this is the bin, the side bin, the bin here. This is the conduit and pipe. We lay the conduit and pipe before pouring the concrete. The bin is here. We have a bin here. This is the ceiling strap. This is the bin. Okay, talk about walls. For small house, the wall is like this. Big wall, you see. For cold area, you see we have double layer of walls. You see, we call it cavity wall. And this is the dam-proof course. This is for old and small building. This is the cladding, the aluminum cladding for the outside wall. Maybe for the warehouse and factory. For in-situ concrete, we use timber formwork. You see like this, with a reinforcement for the wall. This is the door jamb, the door hole. You see, so we pour the concrete here. So it is timber formwork. This is a long time, a lot of labor. So we invent the steel form. It's faster. You see, it's one big form, big form. It's made of steel, aluminum, or even plastic. And then we have the slip form. Slip form is the climbing form, or we call it, because we use the hoist. This form, floor by floor. You see, after curing of the concrete, we hoist it upward. So we call it slip form. Climbing form, we call it. It's the gas curtain wall, not very common for the exterior wall. Roofing. Now we see this kind of roofing is simple roofing called a tension membrane. This is the membrane, plastic membrane. Use a tension wire for mounting of the membrane. And this is the steel frame tension membrane. This is the frame, the steel frame for very long span. These are common for sports stadium. For common building, we may use the roof truss like this. It's purlin. Use a tile, a ceiling tile, or cladding like this. We call this the truss, metal truss. Of tile, this may be in plastic, or aluminium, or ceramic tile. This is the aluminum cladding. For concrete building, the roof, we need to do the insulation. Insulation, which is polystyrene, expanded polystyrene for heat insulation. And we need to do the waterproofing. The proofing, we use felt, bituminous. And we use screening to fall. This is to fall the water. So this will end our lesson of building structure. Hope you can learn something. Thank you very much for watching. See you. Goodbye.